Hi, welcome to Math Minute. My name is Adam, and today we're going to talk about rules of exponents. So we have a few different categories. We have some general categories when we have the same base, same exponent, and then we have a few special cases which we'll cover. So the same base, that's when we have something like some number a to the power n times some number a to the power m. So when we have this, we can add these two together. This is our first rule, and this is multiplication rule when we have the same base. So once again, we're learning about things that have just letters, which is confusing and not very practical, but at least it's a way we can understand it. So let's explain this, why this works. So based off this, we have 2 to the third times 2 squared. So 2 is our base, we have a common base, and we have different exponents. So n is 3, m is 2. From this, we can say that this is going to equal 2 to the fifth, but why does it equal that? Well, let's write this out. Let's go back to what we know about exponents. So if we have 2 to the third, that is just 2 times 2 times 2, right? Now if we have this times 2 squared, which is just 2 times 2, from this we get 2 times 2 times 2 times 2 times 2. So now we have 5 of these 2's, which is just 3 plus 2. So that's 2 to the fifth. So what we're doing is we're breaking this down to what we know it originally was, times, which is 2 to the fifth, adding them together. So division is kind of similar. We have another rule where we have a same base and to some exponent powers. When we divide the two, we can say the top power minus the power underneath. So the power in the numerator minus the power in the denominator. So based off this, we know that this is going to be 2 to the 3 minus 2. It's going to be 2 to the 1, which is just going to be 2. Why is that? Let's work this out again. 2 to the third, 2 times 2 times 2, divided by 2 times 2, 2 squared. So this, though, what we know about division is we can cancel these out. So we're left with just 1, 2. So the answer would be 2 to the 1 power. So we've just shown why this one works as well. Now with the double power, this one gets to be a little more complicated. When we have some value to a power, that whole thing to another power. So what that's going to be is we can multiply these double powers together. So in this case, this would say that 2 squared to the third power is going to be 2 to the sixth power. 2 times 3 is 6, 2 to the sixth power. Why is that? Well, let's break this down. If we have this to the third power, we're multiplying this 3 times. So 2 squared, 2 squared, 2 squared, 3 times. But what do we know about this? This is just 2 times 2. So 2 times 2 from this, times 2 times 2 from that, times 2 times 2 from that. Let's count up the number of 2's we have. 1, 2, 3, 4, 5, 6, which was 2 times 3. So we know that this is 2 to the sixth based off our rule, and we've just shown why. Now let's talk about the same exponent. Before we were talking about the same base, let's talk about the same exponent. So if we have something times something, a times b, to a power, we can split that up and carry the power through each term. So an example would be 2 times 4 all to the end. And let's change that to the third. So this is like saying 2 to the third times 4 to the third, which is going to equal the same. If we type this in our calculator, it will equal the same as this in our calculator. And similarly from division, we can say a over b to some power n. We can distribute that n through both. So let's do this once again to the third power. We can say this is 2 to the third divided by 4 to the third. Pretty similar idea. Now let's talk about some special cases, some specific examples. This is just something we're going to know. It's hard to explain, but let's just understand it. Anytime you have anything to the power 0, it's always 1. So I could put 2, 3, 7, 8, whatever, and I could put that to the 0 power, it will be 1. Even if I had this to be a variable x, it's going to be 1. We kind of talked about that a little bit earlier in polynomials. So this is just showing that. Now if we have a negative power, what we're going to do is switch from the numerator to the denominator. And this is really important because you'll start to see this in some of the different ideas in math. If we have anything to the negative power, we're going to switch it to the denominator. This is in the numerator. We're going to switch it to the denominator. So if we have 2 to the negative 1 power, that is 1 over 2. Now, if we have 1 over something to a negative power, which is in the denominator, we'll switch that to the numerator, and this is why. We just showed from this that a to the negative 1 power is 1 over a. So this is just 1 over 1 over a, which equals a. So in this case, if we have 1 over 2 to the negative 1, that's just going to equal 2. Now, one other idea is fractions as power. So if we have a to the 1 over n, that's going to equal the nth root. So a really easy example, one we deal with a lot, is what if we're talking about the square root of a? This is just a to the 1 over 2. Now we could change this to 3 to 4. This could be 1 over 7. That would be the 7th root. But this is the specific example, and it's an easy way to understand it. Now we want to combine some of these rules to show an example of something. We know that the square root of x squared is going to be x. They're inverses of each other. They cancel each other out. So let's just show why. So we have the square root of x squared. Now what we just showed here with fraction powers is that the square root is just that to the 1/2 power. So this is just x squared to the 1/2. Now there's another rule on here that we can even go further with this. We have a power and another power on the outside, so we have a double power rule. And that says we multiply these together. So this is x to the 2 times 1/2. 2 times 1/2 is 1, so x to the 1. And that's why that's the case. So every time you do this, and we've been doing this for a while, we've always just assumed it was x. But it's really from these rules of exponents that we can say that that's true. So this has been an overview of rules of exponents. Hopefully they'll help you with solving some of your equations, and we'll see you next time.